Welcome back, ladies and gentlemen. Here you can see we've got our third unit, Dynamics of Ecosystems. We're going to be taking a look at how the world around us works, the living world specifically. And sort of the running theme we're going to see here is that, broadly speaking, humans want simple answers to complex problems, but the world is a big and complicated place. There are still simple answers to be found, but they take a lot of work to get to refine, and to create. So we're going to be looking, as always, for patterns and understanding of larger systems. But first, we're going to need to do a little bit of review. Hopefully some of this stuff is pretty familiar. Yeah, here's one cozy, clean pond located in a warm grassy area, plenty of mud, and it's on a golf course. Never mind. So we're going to start with some fundamentals. Keep it simple. Roles in an ecosystem. We got the simple name and the complex name. You're pretty familiar with the simple name, I bet. Producers and consumers, think you've seen those before. You may not know autotroph and heterotroph. These two basically mean the same thing as producer and consumer, but these using some Greek because that way we sound smart. And they basically mean the same thing as you can see here, right? So these are plants and some other microorganisms that use photosynthesis to make their own food. This uses energy to make their own food. So that's, again, photosynthesis to a plant of some form. All right. Herbivore literally means plant eaters. Vor means eat, herb means plant. Carnivore means meat eaters. Omnivore means all eaters. Omni means all or everything. All of these just mean the same thing. Detritivore is literally garbage eaters. Detritus is garbage. It's a fancy way to say garbage. So, each of these guys consume a different type of initial energy source. All of these are technically, if we use the word from the last slide here, heterotrophs, because all of them need to consume something to live. But each of them consumes something different. Herbivores, of course, consume plants, meat, everything, and garbage. Technically, eating the, say, garbage that is the decaying remains of an animal would kind of make these guys like a carnivore, sort of. Whereas if you were to only eat the decaying remains of a plant, that would make you a herbivore, sort of. But we still separate these into a different category just because, well, we like categorizing things and because it's useful. These type of organisms here serve a different purpose in the overall scope of everything. Here we can see some examples: vultures, dung beetles, maggots, fungus. Don't they sound great? There are two types of detritivores: scavengers and decomposers. Scavengers are sort of a visible organism that feeds on dead plant and animal remains like a vulture. So this is a group of vultures here, and they are large enough that you can see. So we call them scavengers because they primarily go after already dead animals and plants, well, in this case animals, but they're another animal that we can observe. Decomposers tend to be microscopic organisms that feed on dead plant and animal remains, such as mushrooms, for example, as we see over here. These are digging into the tree, and they're slowly consuming this tree log. Now, the question is the tree log alive or dead already? Hard to say. Probably dead, which means that it's slowly decomposing, breaking down the tree. Okay, so those are some basic categories that you guys hopefully know. Now we're going to see a few others. There's one here. This is pronounced niche. Often it's pronounced niche in English, but it's niche. The place and role occupied by an organism in an ecosystem, determined by its nutritional requirements, habits, etc. So the niche is sort of what they do. And again, this is one of those pattern recognition things. Vultures, for example, are scavengers. So are hyenas. Both of them exist in different environments, but they kind of do the same job. So we group them together into the same niche to make it easier to understand them. This is the same thing that we did many times throughout this course when we were looking at other stuff that we could group together, such as the families in chemistry or different similar terms in physics. We're always trying to group things into categories because it makes our life easier. Why do extra work when we don't need to? Exactly. Exactly. A keystone species. This is a weird one. This is an organism with a large impact on their environment despite a small number of organisms. So I'll ask people, what's a keystone species? And they'll be like, trees in a forest. And it's like, okay, that's not quite right, because a large impact with a small number. There are a lot of trees in a forest. If you've only got one tree, it's not a forest, it's just a tree. So a keystone species is sort of an unusual one. Things like wolves in Yellowstone Park or elephants anywhere that there are elephants. There's not a lot of those animals, but they have a huge impact. Now, usually at this point, I would show you guys a video. I'm not filming a video of me showing you a video. The link to the video is in the plan. Take a look at it. It talks about wolves in Yellowstone Park. And it's a pretty cool video. It talks about the elephants as well. But one last thing for us to understand is that there is a top predator. This is the last or top link in a food chain or web animal who is not preyed upon, aka, generally speaking, us. We're top predator. And all of these should be key terms that you're familiar with. Oh, yeah, there it is, us. Is there a disadvantage to being the top predator? Yeah, you need more food. This is a big deal, right? Because we don't get eaten, generally speaking. Occasionally, an animal will try to eat humans, but what usually happens when they do that is that we go find that animal and make sure it never does it again. I've told students that before, and they go, "Oh, really? Do we like convince the animal nice?" No, we kill it. If a tiger or a lion becomes a man-eater where they attack humans, we make sure that it doesn't get a chance to do that again the moment we find out, because that's kind of how we make sure that nothing tries to eat us. The other animals have learned humans are dangerous. Keep away from them. And this is important because, well, the animals we can't teach that, like, say, mosquitoes, won't leave us alone. And I'm sure you know mosquitoes are very annoying. Let's take a look here at ecosystems, right? So ecosystem is all the organisms interact in an area through the transfer of matter and energy. So basically, it's a way that we sort of group a bunch of organisms together and say, all of these organisms here are related in some way. They're all different, right? Different colors in my marker box here, but their proximity, their closeness to each other, allows them to interact in some way. Now, the physical environment and the living things in that environment mean, for example, that it's important to consider stuff like the rocks and the air and the water, along with the vultures and the hyenas and the lions. Abiotic factors are the name that we give to non-living things. A in this case is a prefix from Greek that means not everything else. So not biotic. Biotic means living things. That's it. So there's the living things and the not living things. Non is another version of a prefix that means not. So like non over there just means, there we go. Non over here just basically means not whatever the next word is. Abiotic is just another way to do that same thing. Food chains, you've seen these before. You know how these work, right? The snail is going to eat the pondweed, the minnow, the snail, the perch, the minnow. Pretty straightforward. You guys started learning that in what? Grade 3? Grade 2? Something like that. Food webs are a little bit more complex, and they show that the transfer of energy is not linear. It moves around in weird swirling ways. So for example, this woodpecker right here eats cactus, but it can also eat some insects here, like the grasshopper and the red harvester ants. So a lot of different things all eat multiple things, and that makes sense. I mean, you eat more than one thing every day, probably. I hope so. And so you've got a diverse diet, and so do these. You can see here that this woodpecker, for example, ends up interacting with both plants and animals. You've got the sort of orange lines and the green lines there, right? So that means we know that that woodpecker is an omnivore, eats all. Well, at least it's an insectivore. Whether or not we decide to make that a separate category depends on how specific you want to get. But you'll notice the red-tailed hawk is right on the top. The red-tailed hawk is the top predator of this food chain, assuming that you ignore humans. Nothing stopping us from eating that guy. Probably not good eating, although he might taste like chicken. Now, mapping all the food webs is a challenge because of all the possible differences across the ecosystem. This has led scientists to grouping animals into categories or trophic levels based on their features. This is kind of like the chemistry families on the periodic table. Each step in the series of feeding relationships in the food chain or web. What do I mean by that? Producers are in the first level. Primary consumers in the second level. That'd be like herbivores. Secondary consumers, like carnivores and omnivores, that eat the primary consumers are in the third level, and so on and so on and so on. Now, what does this look like? Let's get a picture up here. Okay, here we go. It's called an energy pyramid or a biomass pyramid, or, well, we'll see. Either one, really. This pyramid breaks down how you can group people into different categories. And what we're basically saying here is, if we come back a couple slides here, look at this, right? All of these ones down here at the bottom were producers. And you'll notice that all the green lines are one step removed. So then you've got the woodpecker, the squirrel, the rat, the grasshopper, and the ants. All of those, oh, and the mouse. All of those are one step removed. But some of them are two steps removed. Those are the ones that have got the orange lines to them. Some are three steps removed. Those are the red lines. Some are four steps removed. That's the purple line. So rather than try to map out all these twisting and twirling things and trying to make sure you can make sense of it all, what we do is we just group them into very broad categories. All of these guys eat producers. All of these guys eat the people that eat producers. That kind of thing. What does it look like? Here it is. We've got ourselves a triangle like a pyramid shape, and we've got here at the bottom our producers, or our fancy word for that, autotrophs. Then we've got the heterotrophs that make up the rest of it because they eat things. Primary consumers, they're the first type of consumer, the secondary consumer, the tertiary consumer. Each one of them is going to produce energy by eating something else, specifically the things below it. And what you see is that each level, the higher levels are smaller than the lower levels for the simple reason that there's going to be more of these guys than there are these guys. And that might seem weird because you might think to yourself, well, there's a lot of people on Earth. That's true. There's like almost 8 billion people, I think, 7.8 billion people on Earth, but there's probably 7.8 billion blades of grass out there in the field near the school. Okay, maybe not in the field, but in the city here, yeah, there's probably about that many blades of grass. There's a lot of grass, but we'll talk about that more as we go forward. Filling in our information here, right? We've got our autotrophs down here. Our heterotrophs are all the rest of them. Our top predator is right here at the top of the whole pyramid. Our detritivores, our decomposers, do sort of the whole thing because they sort of consume everything just depending on what's going on. Okay, so we filled in our basics. A little bit more, decomposers, scavengers, those are the two types of detritivores that we already talked about. And then finally, all these things require energy to live, and we can trace that chain of energy back to the ultimate source, the sun. Right down there. Without the sun, none of this is going to be possible. Mostly. There are a few organisms that can survive without the sun. Now, there's a reason that this thing has got a triangle shape that you see here. And that's because these trophic levels relate to the amount of biomatter, or living things, at each category. So down here, your primary producers, there's a lot of them. But there's a lot less of those primary consumers, secondary consumers, and tertiary consumers. This biomass pyramid literally is what it's called. Bio meaning alive, mass meaning stuff or material, right? So these markers, they're not biomass, right? They're mass, but they're not biomass. I am because, assuming I'm not a robot, I'm alive. The pyramid shows the total amount of living material available at each trophic level. The area at the bottom of the pyramid is going to be the producer, and this has the greatest amount of living material for the simple fact that there's a lot of blades of grass, as I was just saying. So for another way, there it is. There are 7 billion people on Earth. That sounds like a lot, but there's probably 7 billion blades of grass in Winnipeg alone. In order for you to exist as a top predator, you need to eat a lot of food, and that food needs to eat a lot of food. 50 grams of human tissue requires 500 grams of chicken, which is 5,000 grams of grass, is the example that we've got here. So, yeah, there's a big advantage to being a top predator. You don't get eaten. That's good. The downside is you have to do a lot of eating. And you guys especially see this. I mean, teenagers, if you ask your parents, they'll tell you, you guys eat a lot. You're always hungry. You eat more than your average human adult because you're still growing. But what does that mean? We consume a lot of resources. And as we're going to see, that kind of got a bit of a problem. There's still more to explore with this pyramid just because living things are just that, alive, and they need energy to stay that way. So when a producer undergoes photosynthesis, it converts the sun's energy into a chemical form that it can use. Why does it have to make a chemical form of energy? Well, because, again, barring the occasional robots or aliens in the audience, we are chemical-based life forms that interact with our surroundings through chemistry. So when a primary consumer, the herbivore, comes along and eats the plant, it doesn't get all the energy that the plant produced. This is because most of the energy is used to grow and live. In the case of a plant, it's hard to believe, but they do respire, they do breathe, because they turn the energy that they collect into more plant. They grow in some way, and they need energy to do that. They need chemistry to do that. So when you eat something, you don't get all the energy that that thing produced. Case in point, right? Consumer can only access 10% of the energy. So if 10,000 joules is a unit of energy, but if 10,000 joules of the sun's energy gets absorbed, beamed to Earth, and it's absorbed, it will be absorbed by algae, and that algae will produce about 1,000 joules from that 10,000. A shrimp will then eat the algae, and they'll produce 100 joules of energy. A fish might eat that shrimp and produce 10 joules of energy, and we will eat the fish and get 1 joule of energy. Okay, technically the fish will give us more, but we get 1 joule of energy from the original 10,000 that we started with. What is this basically trying to tell us? The chain of deals here is inefficient. You want to get a lot of energy from something, you're going to need to eat a lot of it. We need to eat 3 square meals a day. In the case of teenagers, maybe more like 5 or 6 with some snacking in the middle there for sure. A snake can eat 1 meal a month. Bit of a difference. Because of this inefficiency, an ecosystem will need many producers to support a few top predators. Put another way, as you climb the pyramid, fewer and fewer animals can be supported by the trophic levels below. Now, we are top predators and omnivores, which means humans can be more efficient by eating plants. You see, if we skip a step or two, we make things a little bit easier. By skipping a step on the pyramid, we get to keep more of the energy for ourselves, but it does mean less tasty steak in our plate. Simple example here, this field of wheat could feed about 100 people if you make some bread from it. Or you could feed all of that grain to a cow and make steak to feed 10 people because of the 10% rule. So we could eat the plants directly because we're omnivores. We can eat plants. We have that ability. Yes, I know you probably don't like vegetables, but you have the ability to do that. And as a result of that, we could feed more people with less overall energy. This option is more energy efficient, but it's not for everyone, though it has been employed during times of hardship like wars and droughts. When World War II was a thing, I know, a long time ago, the British Empire had a problem with getting enough food. England itself, the United Kingdom, that island chain off the coast of Europe, was kind of under a lot of blockade. And unfortunately, they didn't really grow enough food to feed everybody there. That's what the rest of the empire was for. So they needed to solve that problem because they couldn't get enough food imported. So what did they do? Very simple. They stopped growing beef, lamb, and pork. Rather than feed the vegetables direct to cows and then try to eat it, they just fed it directly to people. They were able to increase food production by slashing how much meat they produced. This is a common thread all throughout human history. When you have a lot of people to feed and not a lot of place to feed them, you got to get creative. And that means eating more vegetables. So I want you guys to try some practice here on page 8 to 10. This should be pretty easy. It's just review of things you already kind of know, hopefully. And once you're done that, check the answers. You know they're online. And next time when I see you guys, we'll be going to talk about sustainability and how that relates to you. But that'll be next time. And I'll see you guys then.